Yeah, so let's see if our stream has started already. And then we can get started. Okay, let's see first. So we can start right now. All right, yeah, we're ready to go. So now we have a question right here. Let me show you the question that we're supposed to do, because the question which is in the thumbnail is not the right question. So this is a question right here. They say solve. Well, yeah, this one right here. They say use appropriate method to differentiate. So we have to differentiate right here. So let me show you the rules of differentiation. But before we start with the rules, for the first question, I don't need like rules like that. I just have to know what is the tan of pi. First, what is pi? Pi meaning in math, pi means 1/8. So meaning, if I have a tan pi x, it's like say tan 1/8 x. But a tan of 1/8 equal to 0. So tan of 1/8 equal to 0. So it's like tan of 1/8 x, we know is going to be equal to 0. So that before you differentiate, we know tan of pi. Look, if I can plug in the calculator, I can show you here how you get it, just in case if you don't know. Let me show you here quick with the calculator. I'm on my calculator. Look here, tan, shifty tan, shifty, my apologies, sorry, just a second. Come in a calculator, and that's okay. Okay. Tan, just a tan, not shifty, just a tan. Tan 1/8. Look, what a tan of 1. Tan of 1/8 equal to 0. So tan of 1/8 equal to 0. You see what I was saying? So tan of 1/8 equal to 0. So then, my apologies, I'm sorry. So sorry, mama. I'm sorry. Okay, sorry about that. So then we say, so then we're going to say this is going to be 0. So then it's like say sine of 0, because all this is 0. So sine of 0 so equal to 0. Plug in the calculator, sine of 0 equal to 0. So then we're going to have a square root of 0. What is square root of 0? Square root of 0 equal to 0. So then it means we only have a cos of 0. What is cos of 0? Cos of 0 equal to 1. Cos of 0 equal to 1. You can plug in the calculator, you see cos of 0 equal to 1. Then I can say cos. But if in exam, make sure you show your works, right? Cos of 0 equal to 1. Cos of 0. Oh, my apologies. Sorry. Cos of 0 is going to give you 1. Okay, so cos of 0 equal to 1. So then, that equation is like somebody gave you stuff like this. So if I had to rewrite it, it's just like say f of x equal to cos of 1. Cos of 0, I mean, because this is like a cos of 0, so cos of 0 equal to 1. So all this stuff is like say 1, because cos of 0 equal to 1, because say this is 0, so cos of 0 equal to 1. So it's just the same as derivate 1. So if you derivate, look, you derivate x. This number has no x. So meaning there's nothing you can derivate here, but when you derivate constant number, you get 0. So f prime, when you write this prime, it's like I have a derivate or I have differentiated. So equal to 0. Okay? So that you should remember. When you derivate constant, you get what? You get 0. So then our final answer equal to 0. But you need to show the steps. Okay? In exam or whatever you do, you have to show the steps. Okay? So let's say I'm in your position in exam. So what I'm going to do is, okay, step by step. Let's say I'm doing exam. This is what I'll do. I'll say but, I'll start one, but I'll say but tan pi x equal to 0. And then I'm going to plug it back like I say it's going to be 0. And then I'll say but sine what? Sine tan pi x, but this equal to 0. And then I'll say sine of 0, but this also equal to 0. And then I'll plug back, I'll say 0. And then cos of 0 equal to 1. So then is equal to 1. So I'm going to say f of x equal to 1. And then when you derivate 1, it's going to give you 0. So f prime of 1, we know it's going to be 0, because all this stuff here we know equal to 1. Let's go to the next question. And then when you derivate it, f of prime of x, you get 0. Let's go to the next question. So the next question is more of the rules of derivative, okay? So we have a lot of rules of derivative, but for this case here, this is a quotient rule. Quotient is more than division. You can see we have something on top and something at the bottom. So we have a rules, and the quotient rule says the following. If you have, let's say, function of another function in the division, let's say you got function, and then divide another function as a division, we just make assumption. So this same as say, if you derivate, when you put dash means it's like a derivative. If you derivate, this same as say, start with the denominator. Write your denominator, constant. Okay, denominator must be constant. And then derivate the numerator. So means f dash. And then you always have to minus. And then now you're going to have to flip, means the numerator is going to be constant and differentiate the denominator, and then always square the denominator. So now we're going to do the same thing here. So now let's do practical. So you can say, okay, let's do practical is action wise. So if I derivate p is going to give me p prime of t, right? Yeah, of t. And then I say, wow, oh my God, I need to write down a little bit, right? I'm sorry, I have to write the formula because I was unaware the formula was under my profile. I'm sorry. So for quotient, we're going to say if you have a f over g prime, prime is like derivative. This same is say always write your denominator constant, then derivate the numerator, and then you minus, and then you write the numerator. Now you flip. Numerator is going to be constant, then we derivate. When you put dash, you should derivate, and then what you do is square the denominator. See what I'm saying? So now let's do action wise now. So now action wise, we're going to say, well, according to the equation, since that looked like the quotient is a division, then we're going to say, well, then we know what we'll do. So this is going to be p prime of t equal. So first and foremost, denominator must be constant. That's how we say 1 minus sign t. And then we have to differentiate the numerator. So I can simply say here differentiate, but now it's t with respect to t. That's what I say ddt means to differentiate cos of t. Now, we have a table. Let me show you the table here. This table here is the table of differentiation. If you differentiate sign, you get cos. When you differentiate cos, you get negative sign. You need to memorize. That has to be like a times table. Like 1 times 1 equals 2. It has to be like basic times table. So you have to memorize it. So when you derivate cos, we know it's going to get negative sign. So when you derivate this one, it's going to give us what? Negative sine t. But according to the negative sine t, let me write well, I'm sorry. Negative sine t. And then according to the formula, we have to minus. And then what we do now the numerator is going to be constant. Like we reverse the process. And then the next things, we're going to differentiate the denominator. What is the denominator? It's like say differentiate, let me write here. So we differentiate now the denominator. What is the denominator? 1 minus sine t. But when you differentiate, you can differentiate separate. It means differentiate 1. But when you d dt of 1, we know equal to 0 because that's a constant. Now let's d dt of negative sign. So now we're going to differentiate the negative sign sine t. So don't worry about the negative. Negative you can take behind because negative is just a constant term. So negative is going to go behind. So it's like differentiate sine t. But you can go to your table. You can simply Google this table. Okay, it's on the internet, on in most of the calculus books we have. So when you differentiate sine, you get cos. When you differentiate cos, you get negative sine. So let's come back here and see what do we differentiate. We differentiate sine. Sine is going to give us cos. But still you have your negative here outside. And then when you differentiate sine, you get cos of t. So then we know this is the same as say 0, okay, minus cos of t. But I don't have this, I don't need this 0, so it's like negative cos t. All right. So when you differentiate the whole denominator, it's going to give me what? Negative cos t. So this is going to give me negative cos t. Now we're going to have to over, like how we say according to the rules, square of the denominator. What is your square denominator? It's 1 minus sine t, and then you square. So the next thing we're going to do here, we just simplify. Let's simplify right there. Look, 1 times negative sign is negative sign. 1 times negative sign, I'm going to write aside the answer, and then I'll plug it back. 1 times negative sign is like negative sign t. Negative times negative, positive sign times sign is positive sine x. So it's like positive what? Sine square t, not x. So our answer is going to become sine. Okay, let me move this calculator aside because this calculator is kind of hiding something. I want to make sure everything is visible. Okay, so then we're going to say, I'm sorry about that. So then we say here, okay, so negative is going to give a positive sign times sine square t. So I'm going to replace this stuff here with this one right here. So I'll replace that. Okay, now this is going to be negative sine t plus sine square t. Okay, minus. Okay, negative, we can multiply. Negative times negative, positive, cos times cos square. So it's going to become positive cos square. Plus cos square. So this is going to become plus on cos square t. You see, but we have a rules, okay, of a trig identity. Trig identity rules say if you have a cos square of anything, let's say theta, plus sine square theta, this equal to 1. Cos square of angle plus sine square of angle equal to 1. So it means if you take this plus that, it's gonna give us equal to 1. So I don't have to write again sine square plus cos square. I can simply say 1. So then I'm gonna say this is gonna be what? It's gonna be 1 here. It's gonna become 1. I think I'm missing something. I do believe I'm missing something. Excuse me. Okay, let me just go back a little bit. I think there's a step we just skip, and I apologize. And I truly apologize. Okay, let's come back. Okay, so sine square plus cos square equal to 1. Yeah, I think it's perfect. It's perfect. Everything's fine. Everything's fine. Oh, I'm sorry. I think I skipped something, and I truly apologize. I want to see if everything's okay. Just go back a little bit. Okay, see. So we say, and I apologize. I truly apologize. So when you expand this, because I said got a lot of 1 here. Oh, I forgot the negative here. I'll tell you why. Look, this is supposed to be negative. Now I understand why. That's supposed to be. So, oh my God, I made a mistake here. So what I'm gonna do, face, I truly apologize. I think I made a mistake there, and I can't remember because just so I'm gonna raise this, and I truly apologize. That part here. So I'm gonna raise this one here. Let me do it again. This question number 2. Made some little mistake here, and I cannot remember exactly where. There's a number which I raised by mistake, and I truly apologize. Okay, but I'll do it fast now. With the accurate, okay? And I sincere apologies, work with me. So we're going to say, well, so according to the quotient rule, we say, okay, prime of t, denominator must be constant. This also is going to be an opportunity for you to learn. Sine t, and then we have to differentiate the numerator. You write the constant, then differentiate the numerator. When you differentiate cos of t, you come into the rules. When you differentiate cos, you get negative sign. So this is going to become negative sign. When you differentiate cos, again negative sign, so I'm going to say bracket negative sign. I'm going to pay attention to my sign, okay? And then we say minus according to the quotient rule, which, okay? And then now, write your numerator constant now. It's like you switch the process. And then differentiate the denominator. So you differentiate 1 minus sine t. Excuse me, sorry. When you differentiate this, we know when you differentiate 1, you get 0. And if you go to the table, this minus, when you differentiate sine, you get cos. So it's negative cos of t. So then I'm going to replace this. I'm going to write there inside the bracket, negative cos of t. So this is going to become negative cos of t. And then we over square the denominator. What is the denominator? The denominator is 1 minus sine t square. I understand what did I skip or fix, and I apologize. So now when we have to expand this, so you multiply 1 times negative sign. So when you multiply 1 times negative sign, we can do it aside. 1 times negative sign, because you expand this bracket, you see this is a bracket. 1 times negative sign is going to become negative sine t. And then negative times negative is going to become positive sine square t. So I'm going to replace that with negative sign plus sine square t. You see, that's a mistake. There's a little... You see, that one at face was wrong. So I'm going to say negative sign. I also make mistake here. And then plus or sine square t. But now you go to the next one, you say negative and negative is going to be positive cos times cos square t. It's going to become positive square t. Positive cos square t. But according to the trig identity, we said already, sine square plus cos square equal to 1. So I'm going to replace all this stuff with 1. You see, I had a lot of number there. I don't know how that number was coming from. Big mistake. So we're going to get what? 1. But hey, when you say negative sine plus 1 is the same as say 1 minus sine t. It's like, look, negative, I can simply switch them. You just write one face and then minus sine t. So I can write one face and then minus sine t. So I'll take this sign here like minus sine t, and then I will erase this. So 1 minus sine t, and at the bottom we have a 1 minus sine t bracket square. This and this is going to cancel. So meaning our final answer is going to be 1 over 1 minus sine t. And we're done with the question number 2. Let's go for the last question. So for the last question is actually way easy. And again, a sincere apology, that was my bad. You know, I was a little careless on a second party, whereby I kind of skip a number and it caused a lot of problem, you know. Okay, now let's go to the last one. The last one, I'll just try to go quick a little bit. So we have a rules of ln. Rules of ln say if you have a ln A over, let's say, B, only one ln. This is how the rules apply, okay? This may say ln of A. If its division is going to become minus, and they say ln of B. And if you have, let's say, ln of A times B, means it should not be A and B. Means those A and B can be any functions. So this may say ln of A plus ln of B, because there's a multiplication. So sometimes they can give stuff like that. They say reverse the process. So since you know there's a plus here, so if you reverse the process, it's going to become ln of A times B. You know why? Because there's a plus here. So they can give either way, and you have to do either way, back and forth, okay? Like, and vice versa, like forward or backward. So this may say ln of A over B. Reason we do that? Because this is minus. So we're going to apply the same rule here. But before we start to solve this question, let me also say some very crucial, important concepts. If somebody give you ln of E equal to 1, remember that. Ln of E equal to 1. You can plug that in a calculator and see ln of E equal to 1. Okay? Let me put the calculator. I believe you understand. Just put in the calculator. Let me show you how to put in the calculator, because some people don't know how to put that. So say ln shift E power 1. And you see it's going to give you equal to 1. So ln of E equal to 1. And then another things, if somebody give you, for example, ln of anything, let's say ln of x power 3, you can take any number which is on top as a power here behind. So this may say 3 ln of x is very, very acceptable. Okay? So now let's see how we can apply all these concepts which I have just shown you now into the last question. So first, before, let me say something. So there's two things. There's a very common mistake. Ln of A over B is not equal to ln of A over B, ln of B. Please, these are two different things. The rule which I show you, it does not apply to this. So this is not equal. Okay? So never say this equal to ln of A minus ln of B. No, it's not equal. However, is equal to the first one. Just like I explained, I mean these are equal. Okay, so if you can look at just one ln here. Now let's get back to our business and solve the last question. See how fast I'm going to solve now, because you understand all these key concepts. So then, well, I'm going to say, first I have to split before I start to differentiate. Don't start to differentiate if you can simplify. So I'm going to say there's a ln 1 and then there's a top and bottom. So I can say this ln of EX, and then I'm going to say minus, because there's a division here, ln of 1 plus EX. 1 plus EX. So the next things, if you can look careful, right, we know this X is going to go behind here. So it's going to be X ln of E. So I can simply write here, say, okay, well, that's going to become our g of X equal to, okay, I want to make sure that I write under. I want to write on top. So then we're going to say g of X equal to what? To x ln of e because it went behind here. We have that rule which explained x ln of e because we can take it behind. But, and then we say minus, minus, and they have a ln, and they have a 1 plus ex. But hey, look, very important, ln of e we know equal to 1. I even plug in the calculator for you, ln of e equal to 1. So right there is going to be x times 1. I have to replace that ln of e. So it's like, say, x times 1. Dot means times. X times 1 equal to x. So I can simply plug it. But make sure you explain, and if it's a written assignment or exam, make sure you explain your stuff. So that means when you say x times ln of e means equal to x. So I have not started to differentiate. I'm just kind of simplifying. From here, yes, we can differentiate. Now, let's go to the rules of differentiation. So there's a little things I want to show you about the rules of differentiation, especially for ln. If somebody give you, let's say, derivate ln of a function. When you derivate there, what you do, take your function derivate and then write it on top. So I'm going to say when I derivate f of x is going to give you f prime x. You write on top. When you say prime, it's like you differentiate it. And then write exactly how it is at the bottom. So this is going to become f of x. And you have already derivate. A good example. Let me show you practical, okay? Somebody give you, let's say derivate. Okay, let's say derivate ln x power 8. Derivate. So what I'm going to say here, we know when you derivate x8, because you must take that one and derivate and write the answer at the top. So when you derivate x8, remember this 8 is going to come behind here, and then I'll write my 8, and then write your x, and they say 8 minus 1 equal to 7. You just multiply this number behind here, before x, which is going to be 8, take it behind, and then write your x, and then take the 8 minus 1 equals 7, and then over exactly what you have is going to be x power 8. But we can simplify. Cancel 7x, cancel 7x. So we left with 8 over x. That's all. So we're going to apply the same game here of what we have. So remember here, now we're going to start to differentiate all of them. Okay, let's start with the first one. When you derivate x, you're going to get equal to 1. It's just 1. If somebody gives 3x, derivate 3x is going to give you 3 because this is going to become 1 after you derivate. But when you derivate x, you're going to get 1. Let's go for the next one. The next one, we know that ln. We have to derivate that one. So this one is not going to be gx, no more, it's going to be g prime x. Once you derivate, it's not going to be gx, it must have a prime. So x is going to become 1, but this one here, we said if you have a ln, we have to take everything in front of the ln and then derivate and write on top. So we're going to derivate and write on top. Okay, so I can come here aside and derivate aside. So we know for fix this, or if I derivate aside, right? I'm going to say, okay, all I can do right here, I'll say derivate x means ddx of 1 plus ex. So we're going to derivate that. We write on top. And then that's what I say ddx. But then write the same thing with no derivative at the bottom. So I'm going to say 1 plus ex. So the only thing we have to deal with the 1 on top. So we know when you derivate 1 equal to 0. Derivate 1. Because 1 has no x. Because we got 2 letters here, the first and second one. When you derivate 1, 1 does not have an x. So it's a constant because it doesn't have an x. So it's going to become 0. But when you derivate e of x, it's just same thing. When you derivate e of x, it becomes e of x. Same thing. So 0 plus e of x equal to e power x. So then we're going to say all this stuff here is going to become e power x. It's going to become what? E power x. So far we have a 1 minus e power x over 1 plus ex. So what we're left with now is just a matter of simplification. Let's simplify. So I'm going to say this is over 1, and then I can simply cross, say u and u cross. Now we go 1 times 1 plus, okay, so let's simplify. 1 times all of this is going to become the same thing. This is normal simplification. 1 times all of this stuff is going to become the same thing, ex. Minus, minus. 1 times ex is ex. And then you multiply this 2. 1 times going to become 1 plus ex. So what we do now, if you can look careful, right? This and this is the same thing, but one is positive, one is negative. So it's going to disappear because ex minus ex will become 0. So we don't have to write none of them. Both of them is going to be equal to 0 because we minus them. So our final answer is going to become what? 1 over 1 plus ex. So our final answer, finally, is going to become 1 over 1 plus ex. So it's like a 1 over 1 plus ex. And that's going to be final answer. Okay? Hey, like I say, some of you might be new to my program, and it's not only this. We got a lot of program. I have a other program where I give back to the homeless. Click the link below. You're gonna see what we do. We have a feeding program with a little that I have. Feeding program. They say giving back is not necessarily must be billionaire. So we give back knowledge, food, helping the homeless, kids. You know, dropping out. Some of the kids are dropping out. They have been dropping out from the school. So what I do, I enroll them to the formal education, like go to the departments and enroll them and take them back to school. Or sometimes I provide them some skills, sort of computer skills, also connect them to the right network so they can change their own life, the loved one, and so that they can stay away from the crimes, because I make them believe, or I give them skills so they can be independent, so they're not going to have to have that mindset of, oh, you only have to commit crime, or the crime is the only way out. For that being said, thanks a lot for your time, and subscribe if you face time, like the video, share, and peace, and I'm gonna see you very soon. Bye bye.